I want to show something that's really interesting, which is a demonstration of
On Earth, the simple
how artificial intelligence kind of works. And I want to kind of break this down in terms of explaining machine learning and explaining how this is pretty cool, but how there are limits to it.
On Earth, the simple rules of natural selection and competition led to the evolution of increasingly intelligent life forms. Today, we ask if comparably simple rules and multi-agent competition can also lead to intelligent behavior in a new virtual world. These agents are playing hide and seek. These agents have just begun learning, but they've already learned to chase and run away. This is a hard world for a hider who has only learned to flee. However, after training in millions of rounds of hide and seek, the hiders find a solution.
The key thing to know here is, and this is how machine learning works in general. Machine learning works by essentially you program the parameters of the game that you have this machine learning algorithm play. So if we take chess, for example, you would put the rules of chess in. Pawn can do this, knight can do this, rook can do this. You goal, and then you apply a goal. The goal is to get the king. So you have the rules, and then you have the goal. And then what happens is machine learning works by it runs millions and millions of iterations of of that game. It starts out by doing random activities. If we're talking about chess, it'll move the pawn in front of the king first. Let's just say that's one random move it does. And then let's say it starts moving the king, just the king, to the center of the board. Well, you do that 100 million times, which is what happens in machine learning. And what you'll realize is, okay, we've randomly decided to move pieces, and one of the pieces we moved was the king closer to the center of the board. And we find that as you move your king closer to the center of the board, every time you do that, it reduces the probability that you win the game, because obviously, you don't want your king to be in a vulnerable position. And so then what happens is, after every iteration of the game, it looks at the moves it did initially randomly, and it starts weighing the probabilities of the success of those moves. So a machine learning algorithm will say, okay, every time I move the king close to the board, I lose more and more, so I'm now going to not do that. I'm going to bias action so that doesn't occur. And instead, I'll start by, opening with my knight, which is a better move. What it does is every iteration, it is sort of doing a random activity. Like in this case, the blue guys can move. If it moves to one corner of the map and always gets caught, then it's going to, as iterations keep going, the machine learning algorithm is going to bias action away from that. So it'll say, okay, do something else. And then what happens is when you run that millions and millions of times, you do it randomly initially, and then certain strategies emerge organically that fulfill the goal of the game given the parameters, and that's what an emergent strategy is. So that's what's happening here.
The hiders learn to use rudimentary tools to their advantage. By grabbing and locking these blocks, they can create their own shelter. The seekers are locked in place for a brief period at the start of the game, giving hiders a chance to prepare. Even so, the hiders must learn to collaborate, accomplishing tasks that would be impossible for any single individual. The hiders are not the only ones who can learn to use tools. After many generations of failing to break into the shelter, the seekers learn to jump over obstacles using ramps.
Right. So again, think of that like them moving the ramp. For 10 million iterations, they were just kind of random number seed going in a random direction. And then, some of those iterations, they'd bump into the ramp, and eventually that ramp would bump into this wall to the point where they can crawl over it. And now that's created a line of action that is being biased towards in the algorithm. And those are the emergent strategies. The meta game, when people talk about a meta, the meta in a game is the most successful strategy that organically emerges given the parameters over iterated games. So if you think of something like League of Legends or Call of Duty or any online game, when a champion or a gun gets buffed, then that changes the parameters of the game where, okay, this gun is really good or this champion is really good. The natural organic strategy that emerges as the best strategy in that game is going to be utilizing that buffed champion. And then consequently, if a champion's nerfed or a gun is nerfed, it'll be used less. So there's no explicit rule in League of Legends, for example, that says you have to pick a certain character to play. But if you're trying to win, then organically, better characters are going to be chosen. And that's the metagame. So the metagame is the most successful strategy that emerges organically as a result of iterated attempts at playing the game.